All right, hello everybody. It is Miss Hester. I am going to be making a video for our final exam review. As I said in class, some of the questions are the exact same as they are here, as they will be on the final exam, and all of them that are on here are very similar because I essentially took the final exam, put it in a Word document, changed some numbers around, and hit print. So some of these questions are very similar, if not the same, as they will be on the final. And I know that some of this stuff we have not talked about since January, so that's why we're going over it now, because it's been a while since we've talked about it. So our first topic we're going to talk about is polynomials. And polynomials, if you forgot, it's fine if you did, is where we have a multi-term function. So like this, I have more than two terms, or I have two or more terms. I've got two terms here and I've got three here. So these are polynomials. And one of the first things we talked about with polynomials was operations on those polynomials, like multiplying, dividing, adding, subtracting, all that good stuff. So we're going to start with multiplication. And multiplication follows the distribution property, where I'm just going to distribute everything from one function onto everything of the second function. So we're just going to rewrite here real quick. Okay, so I'm going to start by multiplying my first two terms together. So 4 times 2 gives me 8, and then x times x squared will give me 8x cubed. Okay, so I have 8x cubed for that first term. Then I move on. I'm going to multiply the 4x by the second term in that second polynomial. So 4 times negative 5 gives me negative 20. X times x gives me x squared. Moving on, I'm going to put that 4x onto the last term of that polynomial, which is that 3. 4 times 3 gives me 12, and x times no x's just gives me a normal x. Okay, now I'm not done here. I must distribute that 7 onto everything else as well. So I have negative 7 times 2 will give me negative 14x squared, because I don't have any x's attached to the 7, but I have an x squared attached to that too. So I'm going to keep that x squared there. Okay, then I have negative 7 times negative 5x gives me positive 35x. Okay, and our last one, negative 7 times positive 3 gives me negative 21, and neither of those terms had an x, so that 21 will not have an x. Now, if you stop here, you get partial credit. You do not get full credit, because we must combine like terms from here. Okay, so looking left to right, okay, I don't have any more cubed terms. I don't have any more x cubes here, so my 8x cubed is going to stay 8x cubed. However, I do see a negative 20x squared and a negative 14x squared. So combining those, I get negative 34x squared. Okay, and our other like terms, I see a positive 12x and a positive 35x, which will give me positive 47x. And then that negative 21 just stays the same, because there's no other normal numbers to combine with that guy. So then here, once you get here, you would get full credit, because that is our final answer. We have combined all of our like terms, and we have simplified that down. Okay, so that's multiplication, making sure you distribute each piece onto each piece of the second thing. Okay, now let's talk about subtraction. So subtraction and addition work the same. You're going to end up combining like terms in some way. But what I want to notice here, this is difference, which means I am subtracting. And when we are subtracting, we must distribute that negative onto that second set of polynomials before I do anything, to make sure that I get all of my signs right. Okay, so my first polynomial stays the same. I have 6x cubed minus 7 plus 3x squared minus 2x. Okay, and now since I'm going to distribute this negative onto all three of those terms, I'm going to change that negative to a plus, and I'm going to flip-flop all of the signs. Okay, so this 7 right here is a positive 7, so it's going to become a negative 7x. That positive 2x squared will become a negative 2x squared, and that negative 6 will become a positive 6. Okay, so the most important step with subtraction here is distributing that negative onto all of those polynomials and making sure all of those signs flip. Okay, so now we have addition. Okay, and when we're adding or subtracting polynomials, all we want to do is combine like terms. So I'm going to see what I combine with what. Okay, here I have a 6x cubed. I look in anywhere else in my equation, I don't see any more x cubed stuff, so I'm going to leave my 6x cubed as 6x cubed. Okay, now I'm going to move on to the x squared stuff, because I want this to be in order, because I have OCD. Okay, so I'm going to keep this in order, so I'm going to go to my x squared stuff. So I have a 3x squared here, and then I have a negative 2x squared here. So I have positive 3 minus 2 gives me positive 1x squared. And you don't have to write the 1. If you want to, great. If you don't want to, also great. Okay, moving on to our normal x terms. I have negative 2x plus a negative 7x will give me negative 9x. And then looking at our normal numbers, I have a negative 7 plus a 6 will give me negative 1. Okay, so again, just combining like terms, finding what I can combine with what, and moving on from there. Okay, so now let's talk about division. When we talked about division with polynomials, we talked about two different types of division. We talked about synthetic division and we talked about long division. Okay, long division, as in the name, it is long. Okay, but what I want you to know is long division will work every time. Synthetic division will only work in cases where I have x and then plus or minus a number. Okay, so something that looks like this right here. Okay, so here I'm going to use synthetic division. Okay, but if I notice down here, I do not have just a normal x plus or minus a number. I got x squared. Okay, so this one here, we're going to use long division. Okay, we could, if we wanted to, use long division here, but synthetic division is much faster, and in my opinion, easier. But if you prefer long division, great. Okay, but synthetic division, we're going to use here. Okay, now the setup for synthetic division is a little tricky. Okay, so on the inside, we are just going to take the coefficients of each of our pieces of our polynomial that's up here. So I'm going to have my 2, my negative 3, my negative 4, and my 5. Okay, and then I am going to take this 1 that's over here, flip the sign, and put it on the outside in front of my that first row. Okay, now the first step of synthetic division, no matter what, is to always bring down your first number. So bringing down that 2. Then I'm going to multiply that 2 by this negative 1, which will give me my give me a negative 2. Okay, and then I add these two. So negative 3 plus a negative 2 gives me a negative 5. Then I'm going to multiply this negative 5 by this negative 1 to give me positive 5. Negative 4 plus 5 gives me positive 1. And 1 times negative 1 will give me negative 1. Okay, and then 5 minus 1 gives me 4. Okay, now, so this is only halfway through. Okay, so we've done our synthetic division, okay, but if we notice, we started with a bunch of things with x's. We had better end with some things with x's. However, what I want you to know with synthetic division, we started with a maximum x cubed. We're going to end with an x squared. We have gone down 1 power for each piece. Okay, so our 2 now has a 2x squared, which means our 5 is going to have a normal x, and our 1 will be by itself. Okay, but what do we do with this 4? Okay, this 4 right here, that guy is our remainder. Okay, and if you remember, for our remainder, we're going to do whatever the sign is, so plus 4, but we have to divide it by whatever we were dividing by, and in this case, it was the x plus 1 that was up here. Okay, so we have our normal pieces from this here, but whatever is the last number when we're dealing with synthetic division is always our remainder. And if we have a remainder, we put that remainder over whatever we were dividing by. Okay, so that is our final answer. Okay, so now let's talk about long division. Okay, so as I said earlier, long division is long. Sorry, it's just the nature of the beast. So we have x squared plus 3x plus 7. With long division, minus 7, apologies. With long division, we take everything with the equation. We don't just take the coefficients. We take all of those pieces. Okay, so I've written my my dividend. Now let's talk about our divisor. Now let's write our dividend. Okay, now what I want you to notice here, we started with a 4x cubed, but we went straight from an x cubed to an x. Okay, so we are missing an x squared term. Because we are missing that when we are doing division, we have to have a placeholder. So we have to have plus 0x squared, because otherwise we're going to mess up a little later down the road, and I'll explain what that would look like if we didn't have that placeholder. So then we have our minus 2x plus 4. Okay, so now from here, what I care about is this first term and this first term. Okay, I want to turn this x squared into a negative 4x cubed, because my whole goal right here is to get rid of this. Okay, I want to break down this so that I can get down to a nicer answer. Okay, so I want to change this x squared into a negative 4x cubed. Okay, so right now I have an invisible 1 in front of my x squared, so I want to turn that 1 into a negative 4. How I do that, I am going to multiply by negative 4. Now, for the x piece, I have 2 x's here, 1 x here, so I'm going to multiply by negative 4x, because I just need 1 more x for this x squared term to become an x cubed term. Now, from there, I'm going to multiply everything on my divisor by this negative 4x. So I'm going to get my negative 4x cubed, which is what I wanted. okay, then I'll get a negative 12x squared. This is why we have that placeholder, because if we did not have this placeholder, we have a random x squared term. What do we do with it from here? Okay, we need that placeholder because we will get something that looks like this. Okay, and then negative 7 times negative 4 gives me positive 28x. Okay, now, when we were doing synthetic division up here, we were adding down. With long division, we subtract. So I'm going to put all of this in parentheses, and I'm going to subtract down. Okay, so I'm going to have negative 4x cubed minus a negative 4x cubed. That is going to cancel for me, which is great. That's what I wanted. Okay, do the same thing with the next term. I have 0 minus a negative 12 gives me positive 12x squared. Negative 2 minus a positive 28x gives me negative 30x. And then we just kind of bring this 4 down like we would with normal division. Okay, and then I repeat the process that I just did. I'm going to look at this first term, and I'm going to look over with this x squared again. I want to turn now this x squared into a positive 12x squared. Okay, now again, I have an invisible 1 here. I want to turn that 1 into a 12, so I'm going to multiply by a positive 12. Okay, now if I notice, I already have an x squared here and I have an x squared here, so I'm just going to multiply by positive 12. I don't need any more x's on that term. Okay, so I'm going to multiply that 12 onto everything again. So I'm going to have positive 12x squared, which is what I wanted. I have positive 36x, and then I have a negative 84. Okay, because 7 times 12 gives me 84. And then I'm going to again subtract all the way down. Okay, and those 12x squares, they cancel out, which is great. That's what I wanted. Now I have negative 30x minus a positive 36x, which will give me negative 66x. And then positive 4 minus a negative 84 gives me positive 88. Okay, now I'm going to look at this first term again. But what I notice, I can turn this invisible 1 here into a negative 66, but I cannot turn this x squared into an x. Okay, I cannot figure out a way to do that. Okay, so here I stop because I cannot turn my x squared into a normal x. Okay, unless we get into square roots, and we're not getting into that right now. Okay, so this right here is my remainder. Okay, so my answer is that negative 4x plus 12 minus the 66x plus 88. Now our remainder, just like with synthetic division, we're going to divide it by whatever our divisor was. So x squared plus 3x minus 7. This is what we had left over, okay? So we have to divide it by whatever we were dividing by, okay? And that's it. That's how long division works. Again, this sucks. It's really long. I apologize. That's just the nature of the beast, okay? All right. So that is division. So now let's talk about the next thing we discussed with polynomials, which was one of the most important pieces about polynomials, which was factoring. Okay, and factoring, if you forgot, that's okay. Factoring is when I end up with like x minus 2x plus 1, blah, 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 blah. I have a bunch of sets of parentheses with a single x and a number inside of it, okay? So that's what factoring is. So I want to turn this polynomial right here into, I want to factor it. Okay, so I'm going to rewrite it so I have some room. So I have 5x cubed minus 15x squared plus 3x minus 9. Okay, now normally when we factor, we would do, like the most common form of factoring is the big X method, where if we had like x squared minus 6x plus 5, something like that. Okay, if we had something like this, we would go straight to the big X method. But what I notice here is I have 4 terms and I start with an x cubed. So unfortunately, I cannot do my big X here. Okay, here I have 4 terms. So I will do factor by grouping. Okay, and factor by grouping is where I'm going to group my first 2 terms and I'm going to group my second 2 terms and I'm going to factor out a GCF. So I'm going to completely ignore this 3x minus 9 for now. I only care about the 5x cubed minus 15x squared. Okay, I'm trying to find my greatest common factor. I'm trying to find out what I can pull out of both of these things. And I notice that both of my numbers, I have a 5 and a 15, both of those numbers are divisible by 5. So I'm going to divide both of those numbers by a 5. Okay, I also notice that both of these numbers have some sort of an x attached to them. Okay, one of them is an x squared, one of them is an x cubed. Okay, now I notice that I have two x's here, and I have three x's here, which means I have at least two here because I have three. So if I have three, I must also have two. Okay, so I notice I can take out an x squared from both of those because I can take away two of these three x's and I'll still have something left over. Okay, so once I've taken out that GCF, okay, if I've taken away the 5, I'm just left with a 1, and I don't have to write the 1 if I don't want to. I've taken away two of my 3x's, so I'm left with 1x. 15 divided by 5 gives me 3. And I took away both of my 2x's that were attached to that 15, so I have nothing attached to that 3 now. Okay, so that is how this first part of factor by grouping works. I take out my GCF from these two terms, and this is what I have left over. So now let's see if I can do something similar here. Okay, so I'm ignoring these. I've already worked with this. I don't care about now. Okay, so let's see what I can take out of these. Okay, so I notice that both 3 and 9 are divisible by 3, so I'm going to divide those by 3. I'm going to put a positive 3 out here. Now, neither of them have an x attached. Well, one of them has an x, and one of them doesn't. So I can't take out any x's here. So the 3 was the only thing I could take out. So I'm left with x minus 3. Now, what I want you to notice, this factor and this factor are exactly the same. That is the goal of factor by grouping. If these two things were not the same, this didn't work, okay? And we would have to do something else. But more often than not, hint, wink, wink, hint, hint, wink, wink, okay, this will work, okay? So our two factors, our x minus 3's will combine into a single factor of x minus 3. And then we're going to take whatever we had left over, so our two GCFs, so our 5x squared and our positive 3, and that'll become our second factor. So we have 5x squared plus 3. And that is our second factor. And this is our factored form of this nasty polynomial. Okay, that is what that's going to turn into. And we would stop here because I can't do anything else here, and I can't do anything else there. So that is our final answer. All right, so that's factor by grouping. Essentially, just group the first two, group the second two, factor out your GCFs, and you're good to go. All right? Okay, moving on. Okay, so we had a brief discussion about roots before spring break. So I know it's been a fat minute since we've talked about it, so let's talk about it. Okay, one of the main things about doing roots is how do we undo a root, and that's raising it to whatever power that root is. Okay, so for example, if we wanted to undo a cube root, we would raise something to the third power. If we wanted to get rid of a fourth root, we'd raise something to the fourth power, etc., etc., etc. Now, if we notice the root that's here doesn't have a number in front of it, which means it is implied to be a 2. It is a square root. Okay? Now, to solve square roots, you get the root by itself first, okay? And right now, my root is not by itself. I have a positive 6 out on the end. I have to get rid of that before I can do anything with that root. So I'm going to subtract 6 from both sides. So I have square root of 3x plus 5 is equal to 4. I just subtracted 6 from both sides to get rid of that. Now my root is by itself. Okay, so now I can undo that root. And as I said a minute ago, there's an imaginary 2 right in that root. So that means I'm going to raise everything to a power of 2 to undo that root, or I'm squaring both sides. Okay, so I'm going to square both sides to get rid of that root. Okay, so I have 3x plus 5 is once I square a square root, that square cancels and the root cancels, and I'm left with whatever was underneath. And I'm equal to 4 squared gives me 16. From here, this is an Algebra 1 problem, if not an 8th grade math problem. Subtract 5 from both sides. I get 3x is equal to 11. So then my x is equal to 11 over 3. Okay, and that's my answer. All right, so with roots, the main thing I want to get out of this is you have to get that root by itself before you can raise everything to a certain power. If you don't do that, you're going to mess up. Okay? All right, so let's talk about rational equations. Okay, so rational equations is what we talked about after spring break. Okay, and what we did with rational equations, we did a lot of adding, subtracting, multiplying, dividing, all that good stuff. Okay, but we also did solving. Okay, and when we were doing solving, there were two methods. There was one where we just did cross multiplication, and there was the method that works every time, which is the method we're going to practice right now. Okay, so when we're solving rational equations, the main goal with most of the time with rational equations is to get a common denominator. If we don't have a common denominator, we're going to have some problems. Okay, but if we can get a common denominator, our life is a whole lot easier. Okay, so to get that, we are going to simplify all denominators as much as humanly possible. Okay, so here I'm going to look left to right to see if there are any denominators that I can simplify. So I have x plus 3, can't really do much to that. X minus 3, can't do much to that. But I see an x squared minus 9. Okay, if you remember, we can do something very special to that. We can do what's called difference of squares, where I create two factors, okay, and I take the square root of both of my original terms. So the square root of x squared gives me x, and the square root of 9 gives me 3. Now, these two factors, one of them is minus, one of them is plus. Okay, so I'm going to rewrite my problem. I have 1 over x plus 3. This left side did not change. 8 over x minus 3, x plus 3. Now, what I notice is, hey, this denominator right here has both of the pieces of my other side. Huh, that's pretty nice, because that means this right here is my common denominator. I have two pieces on my other side that are the same as both of those pieces underneath. So in this case, this right here is my common denominator. Yeah, I ran out of space, but it's great. Okay, so when we did this, to get that common denominator onto everything, we're going to multiply the numerator by whatever we're missing. Okay, so in the first case, I have an x plus 3, but I need that x minus 3. So I'm going to multiply my 1 by the x minus 3. Then for the 6, I have the x minus 3, but I need that x plus 3. Okay, and the 8, I already have both pieces. I got to do nothing to that guy. Okay, now once we have done that to all of the numerators, I don't need to write denominators again, because if all of my denominators are the same, then their numerators have to be the same. Okay, so then we distribute everything. 1 times anything is just that thing. So we'll have plus 6x plus 18 equals 8. Combine like terms, we have 7x plus 15 equals 8. So then we get 7x is equal to 8 minus 15 gives me negative 7, I believe. Yeah. And we divide by 7, x is equal to negative 1. Okay? And that is that. Okay? So the main thing about solving rational equations is getting that common denominator. If you don't get the common denominator, you're going to have a world of trouble. Okay? But once we were able to get here, this is an Algebra 1 problem. Okay? And that is something that we definitely know how to do. Okay? So that is solving for rational equations. Now let's talk about division. Okay, so division of fractions just in general. Before you do anything, you must do keep, change, flip. Okay, keep the first fraction. Change the division to multiplication and flip that second fraction. Okay, then we are going to simplify everything that we can. If we see something we can simplify, we're going to simplify it. Exclamation point. Okay, so if I notice on the top left, so my x minus 6, I can't really do much to that, but I see down here, I see something I can do big X to. So I'm going to rewrite, I have x minus 6 divided by, let's see what that's going to give me. So I have multiply to 24, add to negative 8. Okay, so it wouldn't be something from Miss Hester if we didn't have a typo. This should be a negative 10. Okay, so if we do that, we get negative 10 down here. Okay, so then we have negative 6, negative 4. So then we would have x minus 6, x minus 4 down on the bottom. We have multiplication, and then I notice on the top right, I have this guy right here. Okay, that I can also do big X too. So I'm going to have multiply to 4, add to negative 5, negative 4, negative 1. And we're going to have x minus 4, x minus 1, all divided by x minus 2. Okay, so now from here, I cancel out whatever I see on the top and the bottom. Okay, so I notice I have an x minus 6 up here, and I have an x minus 6 down there. Those go away. Okay, looking down here, I see an x minus 4 on bottom, and I see an x minus 4 up top. Now, my x minus 1 and my x minus 2, those aren't the same, so I can't cancel them out. So I'm left with x minus 1 over x minus 2. And that is my answer. Okay, so with division, the main thing that I want you to know, that keep, change, flip is the most important piece. Okay, if you don't do that keep, change, flip, you're gonna get stuck and you'll get something really, really wonky. Okay, you won't get a lot of cancellation if you don't do that keep, change, flip first. Okay, all right, so now let's talk about addition, subtraction, all that good stuff. Okay, so when we're doing addition or subtraction, just like when we're solving, we want to find a common denominator. If we find that common denominator, our life becomes really, really nice and easy. Okay, so when we do that, again, we're going to simplify each piece that I can see. I can't do anything to those first two fractions, but let's see if I can do something to this guy. Okay, using big X, I want to multiply to -2, add to -1. Let's see, -2, +1. Okay, so then we're going to rewrite. Our first two fractions did not change. Plus, and I can't do anything with that top part. That's just nasty. It's x squared plus 2 all over x minus 2, x plus 1. Okay, so from there, I notice again, like we have when we were solving, these two pieces are the same as these two pieces. Okay, so I'm going to multiply by whatever I'm missing. So my x plus 1, I have this. I need that x minus 2. So I'm going to multiply that 1 by my x minus 2. I'm going to multiply the x by my x plus 1 because I have the x minus 2, but I need that x plus 1. And then my x squared plus 2 already has both pieces, so I don't need to do anything to that. Okay? And then we're divided by our common denominator now. Now, from here, when we were doing rational functions, I saw a lot of people who wanted to just do doot, doot, and cancel out. Okay? That is undoing all of the work that we just did to get that common denominator. Okay, so when we are doing addition and subtraction, do not cancel out until the very end. So I'm going to put that do not cancel, that's not how you spell cancel, cancel until the end. Okay, so I don't want to cancel anything just yet. Okay, I'm going to distribute and see if I can do anything to get that. Okay, so I have x minus 2 minus x squared plus 1x plus x squared plus 2. Okay, and what I'm going to do now is I'm going to combine like terms on that top part. Okay, so looking here, I have, let's see, I have a positive x here, so that's 2x. Okay, my -2 and a +2, those are going to get rid of, those are going to cancel each other out, so those are going to go away. Then I have a -x squared plus an x squared. Those are also going to cancel. So I'm just left with 2x on the top, which is really nice. And then I have x minus 2, x plus 1 on the bottom. Now, what is different about about solving rational expressions and adding or subtracting them is I keep this common denominator there. Okay, otherwise my answer doesn't stay the same. When I'm solving, I'm looking for x is equal to a number. If I'm adding and subtracting, I'm looking for something more along the lines of this. Okay, so kind of keep that in mind as you're doing that. Okay, so that was it pretty much for rational expressions. Now let's talk about something a little more recent, and let's talk about inverses. Okay, so when I give you a function, okay, I always am able to find some sort of an inverse. Now, if that inverse is a function or not, that's a good question, okay? But to find an inverse, the very first step and the very most important step is to flip x and y. If you do not flip x and y, you are not finding an inverse. Okay, now remember, f of x is the same as y. So I have y is equal to 7x minus 2. Flipping x and y, I get x is equal to 7y minus 2. Okay, and then from there, I solve for y. Okay, so I'm going to add 2 to both sides. So I have x plus 2 is equal to 7y. Divided by 7, I have y is equal to x plus 2 divided by 7. So my f of inverse of x is equal to x plus 2 divided by 7. Okay, so the main thing about inverses, if you want partial credit, hint, hint, wink, wink, flip x and y. Okay, because that is the most important step about inverses. Okay, is flipping the x and the y. Okay, so now let's talk about the tables. Okay, so same thing with inverses. The most important step is to flip x and y. Okay, so if I have this function right here, this is my original, and I want to find its inverse, I am literally just going to swap these two things. So I'm going to have a 5 here, negative 3 here, 10, negative 2, 15, negative 1, 20, 0, 25, 1. That's it. Okay, so again, with inverses, the easiest thing, or not the easiest, the most important thing is to flip x and y. Okay, so now let's talk about the most recent stuff that we have talked about, or that we have gone over recently, and that is logarithms and exponentials. Okay, so with logarithms and exponentials, those two things are inverses of one another, and that's why we went over inverses before we started talking about them, as I wanted you to understand that logarithms and exponentials are inverses of one another. So one of the first things that we talked about with these two things is how to go back and forth between the two. Okay, so when we started this unit, we talked about this idea of a base. Okay, and a base with an exponential is the big number, is the thing that's being raised to a number. So this is our base. Okay, whatever is in the exponent is our power, or our exponent, depending. And whatever is on the other side is our answer. Okay, that's how I like to think about them. That's our answer. Okay, so when we're going back into a logarithm, we have log base of our answer is equal to our power. And so all we're going to do is to put it into log form. The most important part is to start with a log, because this is a logarithm. And our base is an itty bitty number. It's a subscript within our log. Okay, it's just telling us what type of log we have. Okay, then we're going to have our answer inside of our logarithms. We'll have our x, and we are equal to our power of 9. Okay, so that's how we go from an exponential to a logarithm. So let's go backwards. Okay, so going backwards, identifying each piece. We have our base of 8. We have our answer, which is x, and we have our power, which is 3. So to go to our exponential, we have our big base of 8, power of 3, not x, and we are equal to our answer, which is x. Excuse me. Okay, so that is that guy. Okay, so now let's talk about some of these real-world application of exponentials and logarithms. And one of them deals with money. Everyone likes money. Okay, specifically compound interest. So compound interest. Okay, and if you forgot the formula, I didn't have you memorize it, so don't worry about it. It is A is equal to P times 1 plus R over N raised to the NT. Okay, so how much money will be in an account that earns 8% interest compounded monthly have after 3 years if the initial investment is $550? All right, let's parse through this. First of all, our equation. A is our final. P is our initial. R is our rate as a decimal. N is number of times compounded. And T, per usual, is time. Okay, so now let's look at each piece. Okay, so it's asking how much money will I have? So we're asking for our final. So A in this case is our question mark. It tells us we earn 8% interest. So our rate is 0.08 because we got to transfer that to a decimal. Okay, we're compounded monthly. There are 12 months in a year. So N is 12. T is 3 because it's telling us time is 3. And our initial, so P is 550. And from there, I just plug it in to my equation. I don't know what A is. 550 is my P. 1 plus 0.08 divided by 12 raised to the 12 times 3. And from there, that's just a calculator problem. I don't have my calculator on me, but that is calculator. And if you have questions on how to plug that into a calculator during the test, please call me over. I am more than willing to help you out with that. Excuse me. Okay, so now let's talk about when we were dealing with transformations of exponentials and logarithms. Okay, the main thing about exponentials and logarithms is there are so many different types because there are so many different types of bases that we can have for these types of functions. And so finding the transformations is a little different than what we've usually been doing when we find those transformations, okay? So when we're dealing with exponentials and logarithms, you have to be given this parent function, okay? So this right here is our original. Okay, and we have to figure out what the differences are between our original to the new function. Okay, now looking at our new function, I see a lot of things. Okay, so I see this negative out here. If we remember, negatives cause reflections. So this negative right here is a reflection over our x-axis because it is out in front of everything else. It is the first negative we see. It is a reflection over the x-axis. All right, so now let's look at the 2. The 2 is in front of everything. What I want you to know here, the 2 is not our base. Our base here is 6. It is not 2. 2 is what is multiplying that 6. Okay, so the 2 is a vertical stretch because it is multiplying our function, and it is bigger than 1. All right, so then we go to this -8 up here. Okay, this -8, or it's after the x, so we have a -8 here, is going to be a horizontal shift to the right. Okay, so remember, everything attached to x's is a little wonky. Okay, I'm going to go in the positive direction 8. All of that sign flips. Okay, and the last thing I see is this +4. This +4 at the very end is a vertical shift up. Okay, it's at the very end of my equation, which means I'm just going to go up. If that was negative, we'd go down. Okay, and you would do something very, very similar with the logarithm. Okay, excuse me. So again, with exponentials and logarithms, the differences between these is this base. This is the type of logarithm we're dealing with. So again, this right here is our original. Okay, that 3 does not do anything to our logarithm. It just tells us what type of logarithm that we have. Okay, so now let's talk about the differences. Okay, so with differences with this guy, okay, I see a, stop doing that. We have a negative out in front of our x, but it is inside of the parentheses, so it is not out in front of our entire function. So this negative here is a reflection over our y-axis because it is inside of those parentheses. Remember, anything inside parentheses deals with horizontal transformations. Okay, and then I also see this 1/2. This 1/2, it is also inside the parentheses, but it is multiplying my x. This is a horizontal stretch by 2. Okay, the main thing about horizontal stretches or compressions is whenever we say the stretch factor or the compression factor, it is the reciprocal of whatever was in the equation. So here I have 1/2, I have 2/1. I didn't write the 1 because you don't have to. Okay, so that is the trickiest, those are probably the trickiest transformations, is those horizontal stretches and compressions. Okay, so now let's talk about this guy, this +3. It is on the right side of our x. It is still inside those parentheses, so we have +3. We're going to horizontal shift to the left. Okay, and then last but not least, we have this -7 over here. That -7 is at the very end of our equation, so we are going to vertical shift down. Okay, so those are the transformations. This is how we identify transformations with exponentials and logarithms. Just look at the differences between the original equation and that new equation. Okay, let's talk about, let's see, what we got. How many problems? 1, 2, 3, 4, 5. Hey, we're almost done. Okay, so determine the following function models exponential growth or decay. So the main thing with exponential growth or decay is we are looking only at the stuff that is inside of parentheses, okay? And growth is bigger than 1. Okay, decay is less than 1. So 0.8 is less than 1. So we have decay. That's it. Okay. So just identifying, looking inside the parentheses. I don't care about this 300, whether or not it's growth or decay. I care about this thing that is getting raised to that x, our base. Okay. Excuse me. All right, so now let's talk about the newest stuff dealing with logarithms, and that was expanding and condensing. Okay, so here I'm going to write out for my reference my 3 log properties. So I have log of m times n, is log m plus log n. The opposite of multiplication is division, and the opposite of addition is subtraction. So that's how we get that property. And then the last property is log of m raised to the n. I'm just going to move that n out in front. Okay, so those are my logarithms. Okay, so we're going to condense first and then we'll expand from there. Okay, so with condensing, I am going to just see if I can simplify anything first, make my life a little easier before I do anything. Here, I can't really do anything to this logarithm, but here I notice that I have a 3 out in front of my log. So condensing that just a little bit, my first log didn't change, so I have log base 5 of x minus log base 5 of y to the third. Okay, because I'm using my power property right here, I notice that I have something that looks like this. I have a number out in front of my log, so I'm going to put that number back in my exponent. Okay, and then look here, I don't have anything I can do to condense that last log, so I'm going to leave it as plus log base 5 of 6. Excuse me. So now from here, which one do I do first, subtraction or addition? Okay, now we talked about this in class. If I had the brackets, if I have parentheses, I would do the addition first, but I do not have those here. Okay, so I'm going to work with just PEMDAS. I'm going to work right to or left to right, apologies. Okay, so I'm going to do my subtraction first. So if I notice, my subtraction is over here. So to undo my subtraction, I'm going to divide those two things. So I'm going to condense it down to one log. So I have log base 5. I'm going to take my x and I'm going to take my y cubed and I'm going to put the x on top. I'm going to divide by y cubed. Okay, so whatever first, that's in the numerator, whatever second, that's in the denominator. Okay, then I have plus log base 5 of 6. Okay, now I can do the addition because I've gotten rid of that subtraction. Okay, and if I remember, addition is the undo of multiplication. So I'm just going to multiply these two pieces. So I'm going to take, I condense down to one log. I have, and I'm going to multiply, excuse me, my 6 by that fraction. So I'm going to have 6 times x divided by y cubed. Okay, so that is how I break stuff like that up. If you want to simplify this just a little bit, you could simplify it to log base 5 of 6x over y cubed, because when I multiply this guy in, I'm only going to multiply it by the x, not by the y. Okay, so that's that. So now let's go backwards. Okay, let's expand. Okay, so with expanding logarithms, I want to get as many logarithms as I can in my final equation. Okay, so I have a logarithm right here. Okay, I'm going to do biggest operation first. And my biggest operation that I see here is division. And by my logarithm properties, I'm going to subtract the numerator and I'm from the denominator. Okay, so I'm going to have log of y to the 6th minus log of 3x to the 4th. Okay, and now I go piece by piece. Okay, I notice here I have a 6 up on top of that logarithm. So I'm going to move that 6 out in front. Log y minus log of 3x to the 4th. Okay, from here, I can't do anything else here because I have my y by itself. But here I notice that I've got a couple things going on. I've got my 3 times my x to the 4th. What I want you to remember here, this 3 is not attached to this 4 at all. This 4 is only attached to my x. Okay, if it were to be attached to the 3, I would see parentheses, but I do not see parentheses here. So I just see the multiplication of the 3 by the x to the 4th. And before I can bring that x to that 4 down, I have to get rid of the 3. So I have to break those two things up using my multiplication property of logarithms, where I break it up with addition. So I have log of y minus, I'm going to put this in brackets because I'm subtracting all of this. So whatever I break this into, I am going to subtract all of whatever I break it into. Okay, so I have minus log of 3 plus log of x to the 4th. And that's going to end the brackets. Okay, so from there, again, I'm looking left to right to see if I can do anything else. Can't do anything else here. Can't do anything to that 3, but I can do something here. I can bring that 4 down from that exponent. So I'm going to have 6 log of y minus log of 3 plus 4 log of x. And now just a final check to make sure I can't do anything else. Can't do anything else here, can't do anything else there, can't do anything else there. So I am done. Okay, so that is how we expand and condense logarithms. So hint, hint, wink, wink, if you want to write this at the top of your test or wherever you have your logarithm problems, that might be helpful. Okay, so that's that. All right, so now let's talk about how we solve logarithms and exponentials. Okay, so when we're solving logarithms or exponentials, you want to get the log or the base by itself. Okay, so for both of these, here in this first equation, or this first case, I want to get that log by itself, and I want to get my base over here by itself. So let's work with the logarithm first. Okay, so when I want the logarithm by itself, is I want nothing attached to the logarithm except for what is inside this logarithm, which is inside this parentheses. So I notice that I have this 5 out here. Okay, so I'm going to divide everything by 5. Okay, so I have log base 3 of 2x plus 5 is equal to 4 over 5, and I can't simplify that fraction at all. Okay, so now to undo a log, take an exponential. Now how I do that is I'm going to create a big base for an exponential that has the same base as my logarithm. So I'm going to write a big 3 because my base of my logarithm is a 3. If that was a 4, we'd have a big base of 4. If it was 112, we'd have a big base of 112. Okay, because when I do that, my logarithm goes away. And that big base that I just added also goes away. So I'm left with 2x plus 5 is equal to 3 to the 4 over 5. And you can plug that into a calculator and you would probably get some sort of a number for that. Okay, so then you would subtract 5 from both sides. So you have 2x is equal to 3 to the 4 over 5 minus 5 divided by 2. And you could just plug that into a calculator if you wanted to. I'm just not because I'm lazy. Okay. But that is how we solve logarithms. The main thing with logarithms, get that log by itself, then take that big base, okay, to get rid of this logarithm. I don't want it there when I'm solving logarithms. Don't want to deal with it. Okay, so then let's talk about number 21. Okay, so as I said a minute ago, I want to get that base by itself. And right now I've got a 4 attached to my base. Okay, so I'm going to divide both sides by that 4. Okay, so now I'm left with e to the 2x is equal to 2. Okay, now when we are undoing exponentials, so to undo an exponential, take a log of both sides. Okay, now what I want to point out here, this is e. This is that funky little number that's kind of like pi but is different than pi. Okay, now if you remember, we have a natural log, or ln, which is that's the fancy way I write ln, okay? And the base of ln is e, if you remember. Okay, so whenever I'm dealing with an exponential that has a base of e in it, I'm trying to solve for x and that x is in that exponential, I'm going to take the natural log of both sides, and I'll show you why here in just a minute. Okay, so whenever I take the natural log of both sides, if I have my natural log, which has a base of e in it, okay, if I have that logarithm that has the same base, and inside of that logarithm I have an exponential of the same base, they are going to cancel each other out, and I am only left with what is in the exponent. So I have 2x is equal to ln of 2. Okay, now I get the x by itself, I divide by 2. So I have ln of 2 divided by 2. Now, the main thing we talked about with these types of problems when we talked about them, okay, this right here, that is a number. Okay, it's a very nasty number, but it is a number nonetheless. Okay, so we have x by itself and is equal to a number. Okay, so here is where you stop. Okay, this is a really nasty decimal. You want to type it into your calculator, great, more power to you. Okay, but that is a number. Okay, so leave it like this. All right, okay, I think that's it. Yep, that's it. So again, with the final exam, it is essentially this review, just different numbers, but some of the questions may or may not be the exact same. I don't know. Okay, so I hope this helped. Thanks for watching. Tune in next year for probably the same type of videos. So like and subscribe to my YouTube channel. Bye bye.